Okay. So the next steps for me in my imaging processing is to do two things. I do hot and cold pixel repair, and you can see the results of this here. See how those hot pixels just go away? That is an algorithm that you can run, and I use Maxim DL for this. I think CCD Soft has a similar feature. I don't know about other packages, I'm sorry.
Nebulosity does this as well.
Okay, cool. I'm not familiar with those. Basically what a hot pixel and cold filter do is they basically say if you've got a pixel that varies by X threshold from its neighbor, it's a bad pixel, and make it equal the average of its neighbors around it. So it'll go through and like it sees that little pixel there and it goes, okay, no way do you have a star that's one pixel, right? We're not a space telescope, so that just doesn't work for us. So it knows right away that something's wrong with that pixel. And similarly, if a pixel is black, and all those around it are a really high signal, there's no way you're picking out one pixel of detail on anything in space, so it knows that there's something wrong, and it'll pull up the signal out of that. Column repair is another great tool that's really important for me. Not so important for those of you who are rich enough to afford the Class 1 chips, which I am not. You need to go ahead and use that tool to repair the columns, and it will go and look at the column and say, yeah, I can see that this column differs from its neighbors on average by this amount, and it'll go up and correct them.
Which one are you using?
I use Maxim DL, column code.
Oh, okay.
Yeah, it definitely does it. Like I said, we can walk through, we'll walk through actually processing the image here.
Jeff, real quickly, in Nebulosity, the guy who developed it basically said if you're going to do dark frames, do dark frames. If you're going to do bad pixel repair, do bad pixel repair. Don't do them both.
I disagree with him. He's wrong. In my opinion, he's wrong. Because you can't map all of your bad pixels with a dark frame. You can't. Now, that said, you can fix that problem when you're stacking. If you're using like a standard deviation or median stacking, those aren't consistent. And what standard deviation and median combines do is they'll say, they're going to look at the value from frame to frame to frame of an individual pixel and go, I'm going to take the standard deviation of those, and it can clip off certain thresholds. So if it's outside this normal range, I'm just going to forget about them and toss them out. So that fixes a lot of those problems. But to say you don't need to do those if you use darks, I think is not right.
It's too concrete.
Yeah, that's a little too black and white. Yeah, it may not be necessary in some cases. For me, it sure was.
It depends on the camera.
Yeah, but again, guys, I've been doing this for like 3 years, so I'm not an expert at all. So again, processing and calibrating is absolutely the most important thing. I'm going to move on because we run low on time. Picking the next sections are really much faster because calibrating is so incredibly important. Calibrate, calibrate, calibrate. Everything has to be calibrated. These images look the same, right? But they're not. The one on the left is significantly sharper than the one on the right. You can see all the detail in the arms, and you just don't see it in the right one. Look through your stack and throw these out. Get these bums out because they will mess up the overall, the end result of your image. You want to just stack the best images that you have. And this is an area where it's great to experiment. Sometimes I will use these bad images. And I'll use them for the darker areas on the outside because they can actually decrease the overall noise of the dark areas, but they'll screw up the real detailed areas. So we'll get to layer masking and how that works later, but sometimes I will use them. It just depends on how my processing is going.
So you do both of them out?
Sequence?
I cheated here. I blurred this, but I've seen stuff like this before where I did
So what you said?
a Gaussian blur has the same effect, oddly enough.
So you said you threw both of those out?
I did not. This is an example where I would definitely toss the one on the right, but I wouldn't the one on the left.
That's what I'm about.
Yeah, I wouldn't toss the one on the left. No, the one on the left is great. Actually, none of these were very good, and we'll get to why in a minute.
Okay.
So this is a CCD inspector, which is a great tool for evaluating the quality of subframes. And if you look, you can see this full width half max. What that is a mathematical model of the size of your stars on average in the image. It looks at the stars, and I'm not going to get into the exact math. Look it up online if you want to, but it runs a formula and says, here's how big your stars are. So you can look at this image. 2.5 arc seconds, 2.24 arc seconds, 2.4 arc seconds, 2.5 arc seconds, 2.57 arc seconds. Notice that these are kind of marching up in value. That's probably a combination of a couple of things. The temperature changing and my focus changing slightly on my telescope, which is why I automatically refocus like every hour or so during an imaging session. It could also be that I'm tracking an object away from the meridian, so I'm tracking down towards the horizon and looking through steadily more and more atmosphere. That's why this altitude measurement on the right-hand side will tell you. So you can go, oh, look, I was getting kind of low on this one, and that's why the frame is getting progressively worse. The bottom image there is the bad frame, and you can see that it's showing 3.42 arc seconds for the full width half max of my pixel, of each of the stars, which is significantly worse than the others.
Is that freeware?
No.
Oh.
I've actually seen it. I haven't bought it yet. But I see, I was going by your chart there until I throw out the bottom two.
Yeah, and you can look at it and toss out the ones that aren't any good.
Does it look at the whole image and
Yes, it
average
gives you
all
the
the
average,
all
yeah.
the stars?
That's right. That's right. It
Interesting.
gives you an
Who
average.
makes that software?
CCDware. This is CCDware creates this. So, and what's interesting is that the seeing. This is the night where Jeff Herman was jumping up and down, screaming about how good the seeing was, and I'm like, 2.2 arc seconds. That's really not good seeing.
Point two?
No, I'm looking at my images. 2.2 arc seconds,
Oh,
2.5 arc seconds. I mean, that's not
Yeah.
terrible.
Point two would be wonderful.
Oh, I'll take that. Want to be Hubble here? 2.2 isn't awful seeing, but it's by no means anything to jump up and down about.
Just what you expect.
So I'm kind of like, what's the deal? Well, here's the deal. My scope wasn't collimated, right? Okay. CCD Inspector also let you look at the curvature of your field, and what this is telling me is, as you can see, this is the dark area is the smallest full width half max. This is a map of the full width half max.
Over the whole image.
Over the whole image.
Wow.
And you can see, this by the way is the stigmatism associated with the RC optical, with the RC optical design. So very corners of the image are a little bit out of focus, a little bit smeared. But my area was right here is where my stars are the smallest. Well, the reason that was the case is my primary was collimated perfectly. My secondary was slightly tilted. So it was shooting
So
an
that
image
color
at
scale
an angle.
represents the size of
That's
the
correct, the size
full
of
width
the
half
stars.
half
That's
max.
That's right. So theoretically, CCD Inspector lets you collimate your telescope in real time, which I tried 2 nights ago. Total disaster. Never do it. It does not work in real time. I mean, and I've talked to like Jim, Vince, a couple of people, and they're like, yeah, we couldn't make it work either. And I'm like, yep, well, at least I'm not alone.
Well, it takes up a lot of real time.
Well, no, it's just that you're like, okay, and it says, okay, well, I'm going to adjust my secondary. Well, I finally got my secondary